Hello students, welcome back to chemistry online class brought to you by ighota virtual learning platform. I am Olabisi Olawaye and I will be introducing a topic to you which is characteristics and nature of liquids. At the end of this class, you're expected to be able to describe the nature and the characteristics of liquids, also differentiate between boiling and evaporation, then vapor pressure. Now, what are the state of matter? The state of matter are classified into different forms. They are solid, liquid, gases, apart from plasma and Bose-Einstein condensate, which makes them 5 states altogether. A matter is anything that has mass and occupies space, and they are made up of different particles which are constantly moving. That is according to the kinetic theory of matter. Now, they are considering the liquid state. The particles of liquids are arranged in a random way and they are close together, though they are not tightly held by strong bonds. Though there are gaps in between the particles that makes them to flow. So it means water can flow, but water cannot be compressed. Solids can also not be compressed, but gases can be compressed because the particles are free. Now, the particles of liquids are held by weak bonds, unlike solids that the particles are held by strong bonds. So water has particles. For instance, liquids generally like oil, water, they all have particles which are weakly held by bonds. And the shapes of water. What is the shape of water? Water does not really have a constant, it doesn't have a shape, it doesn't have a specific shape, though it has volume. It only takes the shape of its container. As seen in the diagram, the different shapes here represent the shapes of the water itself. And it has density. Water has density. Liquids generally has density. They are highly dense, but not as dense as solids. Water, for instance, in ice form, is lighter than liquid water. So this is a result of the hydrogen bonding between the particles, between hydrogen and oxygen of water, between one molecule of water and the hydrogen there and the oxygen of another molecule of water. This is responsible for the density of water, for the high density of water, as an example of a liquid. So liquids generally have high density. They do not have shape. They do not have they have volumes but no specific shape. Now, liquids can also flow and move easily, as stated earlier, because of their particles. They are made up of particles which are held by weak bonds, and this fluidity is a property related to their viscosity. What do we mean when a substance, say a liquid is viscous? This means a liquid is thick and it does not flow easily. So viscosity refers to a liquid's resistance to flow. Definitely water, the viscosity of water is very low compared to honey, for instance. Oil, for instance, is another example of a substance that has high viscosity. So the opposite of viscosity is volatility. A volatile substance dries up faster, it evaporates faster, it flows very well easily, like petrol, like ethanol, all those organic compounds. Some of them, they are volatile, that is, they dry fast and they are not thick. Another example of a thick substance is concentrated tetraol of a 6 acid, which is very thick and does not flow easily. So from here, you should be able to differentiate between low viscous substance and highly viscous substance. A low viscous substance flows easily, like water. Water is a very good example, looking at this diagram, while a thick substance is highly viscous. And from here, we move to the concept of vapor pressure. and saturated vapor pressure. Now, what do we understand by pressure itself? What do we understand by vapor? Vapors are produced anytime boiling takes place, and the increase in temperature also brings about boiling. So when a liquid is placed in a vessel and gets continually heated, the molecules of the liquid are seen to be moving at varying speed in different directions, and this is as a result of what? Increase in kinetic energy possessed by the vehicle, as seen in the diagram below. So we'll see here that anytime boiling takes place, vapors are produced, and that leads us to vapor pressure. Now, when boiling takes place and in a closed container, we will realize that the particles of water will break free. When there's an increase in temperature, the particles break free. That is, the bond holding the particles, which are very weak, the bonds break easily because of the increase in temperature. The particles break free, they escape into the atmosphere. Now, if it's in a closed container, for instance, and boiling is taking place, you will see that as some of these particles are escaping, now they will begin to fill the space above the liquid in the container, and then they begin to collide with themselves and with the wall of the container, generating a kind of pressure called vapor pressure. And because we have different liquids with different intermolecular forces between them, they all have different vapor pressure, and therefore different liquids have their own different boiling point. For instance, now the boiling point of water is 100 degrees Celsius, while that of ethanol is 78 degrees Celsius. So what do we understand by saturated vapor pressure? Or before that, what do we really understand by vapor pressure itself? Is the pressure exerted by the vapor present above a liquid, and the increase in temperature increases vapor pressure. Now, saturated vapor pressure occur when there is a point of equilibrium, that is equality between when the rate of evaporation occur when particles are breaking free from the top of from the surface of a liquid that is boiling, and the particles are in form of vapor escaping into the atmosphere. And then when they are not allowed to escape, the particles which are in form of vapor condenses, that is, they settle down and then fall back into the liquid as water again. So when boiling takes place, particles evaporate, and at a point some of them condenses back, they settle back into the container when they are not allowed to escape. At this point, there will be equilibrium, that is equality between the rate of evaporation and the rate of condensation. And at this point, we have what we call saturated vapor pressure, which is denoted as SVP. So saturated vapor pressure is the pressure generated whenever there is equilibrium between the rate of evaporation and that of condensation. So that leads us to the concept of boiling and evaporation as well. Now, in boiling occur anytime there is an increase in temperature. I told you earlier that when there is an increase in temperature, and matter, which is what we are discussing here, is a liquid matters that are made up of particles begin to boil. And how does that happen? Increase in temperature, we break the bonds holding the particles of liquids together. So these bonds break loose, and the particles gain energy, which is called kinetic energy. Kinetic energy is the energy processed by a body in motion, that is a body that is moving, and this is directly proportional to temperature. That is, anytime there's an increase in temperature, there will be increase in kinetic energy. So when kinetic energy increases, the particles begin to move about, bubbles will be formed, the particles collide with themselves, and then we see that boiling is already taking place. And in this case now, when boiling takes place at a particular temperature, we see that particles will begin to At that point where boiling takes place, there will be a kind of transitioning, that is changing from liquid. The particles of liquid, some of them begin to escape into the atmosphere. They form vapor, and then evaporation takes place at that point. And evaporation is a conversion of a liquid to its vapor below the boiling temperature of the water. So when the temperature is reached, and the temperature is now constant, when the boiling point is reached, the temperature becomes constant. So particles will begin to escape into the atmosphere, and then evaporation takes place at that point. So boiling itself is defined as a phase transitioning from the liquid state to the gaseous state, and it usually occurs when a liquid is heated to its boiling point. Now, and at the boiling point, which is the temperature at which a liquid boils, the vapor pressure of the liquid is the same as the external pressure acting upon its surface. We could see here in this diagram that under evaporation, the particles are escaping, and under boiling, as the particles are escaping, there is a kind of equilibrium between the particles, the external pressure that is acting on the liquid, and the pressure generated by the liquid itself. So boiling takes place here, and at this junction, we like to differentiate between boiling and evaporation. Evaporation occurs at all temperature. Boiling occurs at a particular temperature, and then during boiling, bubbles are formed. Is these bubbles that they represent particles of liquid, and they escape into the atmosphere. So before evaporation can take place, boiling will take place first. So it is after boiling that particles escape into the atmosphere, and evaporation here simply means the conversion of a liquid to its vapor. So at this point too, I would like to differentiate between vapor itself and gas. They sound similar, but they are not the same. So we should not mix them up. A vapor is different from a gas. What is the difference between vapor and gas? A vapor is actually formed from a liquid. That is, when liquids like water, for instance, when it boils, vapors appear. Now, it means that vapor is originally a liquid at room temperature, but gases are constant. At room temperature, gas is in a gaseous state throughout, but vapor is a state of matter that is a liquid at its core, but is now in gaseous state. It changed from liquid to gases. But gas, on the other hand, is a gas throughout. So the main difference between vapor and gas is their temperature. That is, whenever there's an increase in temperature, a gas will still be a gas. Whenever there's an increase in temperature, then a liquid can turn to vapor. So it means that vapor is still in liquid form, but in tiny droplets of liquids. And it is very, very easy for vapor to change back to liquid. But no, that is whenever there's a drop in temperature, and that is condensation. That is, when there's a drop in temperature, vapor, which is in gaseous state, will change back to water. That's the original state. But whenever it is not easy for a gas to change back to liquid, because it's actually a gas at room temperature, except the gas is forced and compressed into a cylinder with high pressure, because that's one of the property of gases. They can be compressed and liquefied. Gases can be liquefied, except under high pressure. Gases cannot change back to liquid easily, but vapor can change back to its original state, which is water or liquid. Now, so what's the effect of vapor pressure on boiling points of liquids? It is found that vapor pressure and boiling point are inversely proportional to each other. That is, as the boiling point increases, vapor pressure decreases. As the boiling point decreases, vapor pressure increases. What do we mean by that? A compound or a liquid that has low boiling point definitely will be volatile. That is, the particles are very, very free and they are held by weak bonds, and like they are not thick or viscous. So it means that such kind of liquid will boil easily. That is, it has low boiling point. That is, low temperature. At a low temperature, boiling takes place in such liquid because it has a low boiling point. Another point, it will generate, as the boiling takes place, more vapor pressure will be generated. That is, more particles will escape and generate a kind of upthrust or force, and that is the vapor pressure. So increase in temperature leads to increase in vapor pressure, but ultimately increase in when the boiling point decreases and a boiling takes place easily or earlier, more vapor pressure is formed. So in that case, the effect of vapor pressure on boiling is that if there is a liquid with a low boiling point, the vapor pressure will increase and vice versa. So, and why is it that liquids have different boiling point? You know, we have all different examples of liquid. It can be oil, it can be water itself, and other liquids, and even chemicals. Now, different liquids have different intermolecular forces holding them. So, hence, the boiling point will be different. So, the higher the boiling point, the lower the vapor pressure. Take for instance now water. Water has a high boiling point because of the hydrogen bonding that holds the molecules of water together in the compound. So water has a boiling point which is 100 degrees Celsius. So because of that, it will generate a kind of low vapor pressure. But for liquid that have a low boiling point, that is low temperature to boil them, they generate more vapor pressure. So it is found that if the intermolecular forces are strong, then the molecules will be strongly attached to each other and the vapor pressure will be low in that case, because boiling will not take place easily and a large amount of energy will be added to separate the molecules. So hence the boiling point will be high, like that's the case of water that I've mentioned. Because of the high concentration of hydrogen bonding, boiling may not take place easily, and that will lead to low vapor pressure. So what do we mean when we say boiling at reduced pressure? It means boiling can take place even when the pressure is reduced, and pressure can be reduced if we use a vacuum pump. That is, when the surrounding pressure is lowered by using a vacuum pump, the vapor pressure needs to be low. The vapor pressure definitely will be lowered to reach equilibrium and boiling will take place. This means the liquid will boil at a lower temperature and pressure. That is, so it means that boiling can actually take place when the pressure is reduced, and pressure can be reduced when a vacuum pump is used, and the function of the vacuum pump is to reduce the pressure. And that leads us to the WAEC revision questions aspect. Now I will leave you now to treat these questions, and then we come back and answer the questions together. All right, so let's treat the first question. Now see the boiling of water in a closed container and also evaporation of water after boiling. Now to the first part of the question, which of the following statement best explain the difference between a gas and a vapor Unlike gases, vapors are liquid at room temperature. That's option A. B, unlike gases, vapor can easily be condensed into liquids. Unlike gases, that's option C. Vapor is readily converted into solids. And D, vapors are generally denser than gases. For option D, it is not true. Vapors are less dense than gases. Some gases are denser than vapor because vapor is lighter than the liquid where it's coming from. Also, gases, unlike gases, that's option C, vapor is readily converted into solid. That is not true. Vapor can only be converted into liquids. So the best answer is option B, which is unlike gases, vapor can easily be condensed into liquids, while gases cannot, because gases are already in gaseous state right from the onset. At room temperature, they are always in gaseous state, while the vapor is from liquid itself, so it can condense back when there is a drop in temperature. So the best option is option B. Number 2, give 2 characteristics features of boiling. The first one is that boiling occurs at a particular or specific temperature, unlike evaporation that occurs at all temperature. And also during boiling, formation of bubbles are present. And what would be the effect of each of the following conditions on the boiling point of water? The first one, addition of crystals of sodium chloride. Now, anytime an impurity is added to a liquid, it will increase the boiling point. So sodium chloride is taken as an impurity here because the water is no longer pure, it's no longer pure water. So because of that, the temperature to break the bonds or to boil of water will increase. So it means the boiling point will increase because an external factor has been added, an external substance has been added. So the temperature that will break the bond will be increased. So the boiling point automatically increases whenever there is increase in or addition of impurity. Also, in the reduction of atmospheric pressure, whenever atmospheric pressure is reduced, definitely boiling will take place faster. It increases the boiling, it reduces the boiling point rather. And in reduction of the atmospheric pressure reduces the boiling point of that substance. That is, the boiling takes place easily rather, because anytime there is a reduction of atmospheric pressure, there will be an increase in there will be a decrease in the boiling point of the water, and vice versa. So state one way in which boiling differs from evaporation. That has been stated earlier. Evaporation takes place at all temperature, while boiling takes place at a specific temperature. The next question, which of the following statements about volatile liquid is correct? Now, one thing about volatile liquid is that they have low boiling point because they boil easily because of the weak bonds holding their particles together. So they are not thick, and so it does not require a high temperature to break the bonds of their particle. So they have low boiling point, and they generate high pressure, vapor pressure, as a result of their low boiling point, because they boil easily and so generate more pressure. And over to the next question. The vapor pressure of a given volume of liquid increases when the liquid becomes saturated with a salt. That's option A. Volume of the liquid increases, temperature of the liquid falls, and temperature of the liquid rises. Actually, vapor pressure increases when there is an increase in temperature. That is, when you increase the temperature of a liquid, the particles gain kinetic energy, bombarding themselves or colliding with themselves and the wall of their container, thereby generating more pressure. So in that case, increase in temperature also increases the vapor pressure. And back to the second question that was treated, that whenever the vapor pressure whenever there is an addition or the reduction in the vapor pressure of a substance, what will be the effect? Actually, boiling will be lowered. The boiling point of the water will be lowered whenever there is a reduction in the vapor pressure. And that leads us to the end of the question. I want you to watch out for the next topic, which is on the nature of solids. And I want to commend your effort for paying attention to the end of the class. Practice more questions. There are more than enough questions under this topic treated, and familiarize yourself with this topic back to back. Take time to go through the questions once again and get the correct answer. I wish you all the best in your exam. Thank you.